So when we're talking about inverse functions, when we were doing the composition of functions the other day, that's kind of how we work with inverse functions. Well, it's how we test them and stuff like that. So the reason for doing composition of functions before inverse functions is you can test an inverse function. There's some steps to finding the inverse. Steps to find inverse. And I'm just going to write them down right now, and then we'll do them with examples. Number one, change f of x to y. Number two, switch the x and y's in the function, right? So if you have an x, make it a y. If you have a y, make it an x. Switch the x x's and y's, x's and y's in the function. Three, solve for y. And four, replace y with this -1 up here, just means f inverse, right? And so we're just going to replace it with the function format. These steps aren't so bad. Depending on the problems that we have, they can get worse. I'm going to shrink this a little bit and move it over to the corner so we can see them as I solve a problem. So say I have my first example, f of x equals 3x plus 1. Nice simple problem, right? If I'm going to follow the rules on this, my first step is going to be change f of x to y. So I'm going to write this as y equals 3x plus 1. Step two, switch my x's and y's. If I have a y, make it an x. If I have an x, make it a y. So here I'm going to have x equals 3y plus 1. Now I have to solve for y, which means I want y to be isolated. I want it to be the only thing on one side of the equal sign. So I'm going to start taking everything off of it. I'm going to start with subtracting 1 from both sides, and I get x minus 1 equals 3y. Now I have 3 multiplied to it, so I'm going to divide both sides by 3, which is going to give me, make a little bit more room, which is going to give me x minus 1 over 3 equals y, right? I'm going to put the y first because I like it that way. But remember here, I have to replace my y with f inverse of x. So I'm going to have f inverse of x equals x minus 1 over 3. Now, the best part of doing inverses is that you can check and see if you did it right. Because if I plug this into my original function, let's see what happens, right? If I plug this in for x in my original function, so my original function is f of x equals 3x plus 1. So if I plug this in, I would have 3 times x minus 1 over 3, right, plus 1. These cancel out, and I wind up with x minus 1 plus 1 equals x. Anytime you want to check to see if you found the right inverse, if you plug it back in, you should get x out. Now, I'm not asking you, I won't ask you on a test to verify, but you can always know if you got a right answer or not by plugging it back into the original problem, and you should get x out. And I think I showed you that a little bit when we were doing composition of functions, that if you plug them back into each other, or they got x's out, it meant that they were inverses of each other. But I hadn't yet explained what an inverse was. So that was a fairly simple problem. Let's complicate it up a little bit. I'm trying to find a good one. All right, let's look at f of x equals, I had a good one and I lost it, x cubed over 4. It looks complex, right? But we're going to follow the same pattern. First, we're going to switch out the f of x and put y equals x cubed over 4. Then we're going to switch our x's and y's so that I have x equals y cubed over 4. And now I'm just going to try and get the y by itself. And remember, I don't want to know what y cubed is. I want to know what y is. Now, I have a 4 in the denominator. The best way to clear a denominator is multiply the problem by that denominator. So I'm going to multiply both sides by 4. And I get 4x equals y cubed, right? Because those cancel. And then the only thing I have left is the cube on that y. Do you guys remember how to get rid of that? Anybody? Come on, pre-calculus. I know it's early in the morning. Well, if it was squared, you would square it. But because it's a cube, you would just cube it, right? So I'm going to raise it to the 3rd power. But whoever said that, yes. If this was a 2, we would square it. But because it's not a 2, we're going to raise it to the 3rd, take the cube root of it, I should say. So I'm going to go to the cubic with the little 3 here, and to the cubic with the little 3 here. And that is going to give me y equals the cube root of 4x, right? When I replace it, I'm going to go f inverse of x equals the cube root of 4x. So really, we're just solving for variables, right? We have all this other little stuff that we have to do, but it's really not that hard. We're changing our f of x to y. We swap our x and y's, and then we're just solving, right? This stuff is just the minutia that goes on around it. So as long as you can solve for a variable, which, please, God, tell me you can, right? At this point, you should be okay with this. Like I said, I'm not going to ask you to verify. I didn't put any in where we need to test and see if they're actually inverses of each other. I just want you to be able to find an inverse. And if I wanted to check this problem, right, I could plug this into the original equation, right? Our original equation was f of x equals x cubed over 4. right? And for x cubed over 4, I could enter in the cube root of 4x cubed over 4, right? And when I cube this, what comes out? What was inside. So I have 4x over 4, and those cancel, and I get x. So I can prove that I found the right inverse, right, by plugging it back into the original equation for x. Like I said, I'm not going to make you verify, but I highly recommend you kind of practice with that when you're doing the problems. Inverses are not difficult if you just understand the steps, if you just follow the steps. Math books will try and make them really complex because they put everything in the formal form, like it would be f of f negative 1 of x to show you that you're plugging the inverse in to verify it. And it makes it look super complicated, but it's not. Just follow this pattern and you should be fine with it. Does anyone have any questions regarding any of this? I mean, I think we did some of it in Algebra 2, but that was a long time ago. Maybe we... All right, well then I am going to stop my video and I'll post it in PowerSchool